Okay, I made a short video today for people interested in using the right triangle calculator. It is a very useful tool. It doesn't matter if you are rusty in trig or if you are a whiz in math. It should be helpful to everybody. I'm going to break it down and put it in English for everybody to understand. So by the time you're done with this video, you should be able to get the angular sizes to things and distances. And believe it or not, it will help teach you and give you an understanding of trigonometry. It's all based on a right triangle or a triangle with a 90-degree angle in it. So if you have the distance of one of the sides and one additional angle, you can fill in the gaps and get the distances of the other two sides and the other angle. Just think about this for a second. If you know the three angles in the triangle add up to 180 and you know that one of them is 90, then that means the other two have to add up to 90. So if you have the one given angle of 45, you automatically know the other angle is going to be 45. And that's just like some of the basic principles on how this works. But let's just get into it. Here's what it looks like. You have sides A, B, and C, and then your two angles are squiggly A and squiggly B. I blocked out the rest because we don't need it for what we're doing. So it all starts right there at squiggly A. That's your observer angle or your sine. Okay, and then you got squiggly B, which is your cosine, which is 90 minus sine. Okay, now you got side A. That's the box that corresponds to it. You got side B. And then you got side C. So whichever information you have is what you type in there. You need one side and one additional angle. So it all starts down at the observer angle. So I'll put a little face down there for you to see. So once again, squiggly A is your sine or your observer angle. Squiggly B is your cosine or 90 minus sine. So if you have your observer angle, you type it in the corresponding box. So that's side A, which is your height, and B is your baseline, and then the hypotenuse, which you rarely ever use. I failed to mention earlier, but if you have two lengths, you can also fill in the gaps. So in this example, I've got 24 for the height and 450 for the baseline. The one important factor is you've got to use the same units. You can't use miles for the height and then feet for the baseline. So if you're going to use miles, you got to convert the feet to miles or vice versa. So that's very important. And I apologize if I'm going too fast for some people. If you need to, just rewind and familiarize yourself with some of this stuff. But let me give you some examples of what you can derive with this tool. Okay, so here I am. I'm the observer. Let's say I want to know the height of a building or a tower. I know the distance. Okay, now I measure the angle and I put them in. It'll give me the height and it'll give me the rest of the information. Or if you want to know the distance and you know the height to it and you know the angle. So it's a very, very useful tool. Another example, if you want to know the height of a helicopter or an airplane from the ground and you know the distance and you measure the angle, or if you want to know the distance and you know the height and you measure the angle. So there's a lot this tool can do. One thing you cannot do with this tool is get the distance or the size to the heavenly bodies. You have to know the distance or you have to know the size. If you have neither, all you could get is the angular size. That's all you could do is measure the angle. And you can do fuck all with an angle. You need more information. Basic geometry. So hopefully we're familiar with all that. So now let's type in, let's do some calculations. So we know the baseline distance or the adjacent is 5,280. It's 1 mile. So we put in 5,280 for the baseline distance. And for side A, we know the height is 100 feet. We hit calculate, and now we get the rest of the information right there. Now it gives us the hypotenuse, and now we know the angle. The angle is 1.085 degrees. Or if we had the angle of 1.05, we could have got the height if we knew the baseline. Here's another example. If we have the angle to something, we measure the angle, and it's 10 degrees. And we also know the height to something. So we know it's 100 feet tall, and with a 10-degree angle, we know that it's 567 feet away. And we know the hypotenuse is 575. So it's very, very useful. one more example. We want to get the height of something that's 15 miles away. So we go to the calculator, we multiply 15 times 5,280, and we get 79,200 feet. Okay, then we measure the angle to it, and we measure a 1 degree angle. So it's real close to the horizon, and it's 15 miles away. So it'll give you the height. So now we know the height to it is 1,382 feet and some change. So once again, a very useful tool, especially in the topic of the shape of the Earth, and for all the debates. It's actually pretty fun once you get familiar with it. But I appreciate you watching. Thank you.